Okay, so today we're going to cover 13.2, talking about angles and angle measure. And so you should update your table of contents and your title page. And whichever student is supposed to be at the board pressing pause, make sure you press pause now until everyone is ready. All right, the first thing that you need to write down for notes is about the angle measure. And the fact that we can talk about positive angles and we can talk about negative angles. Positive angles go counterclockwise from the x-axis, and negative angles go clockwise. Again, hit pause until everyone's caught up. We also have coterminal angles. What that means is that they're in the same position. It gives a little example down below that 420 degrees and negative 300 degrees, they're in the same position, so they're considered coterminal. All you need to do is copy down the highlighted information though. Again, hit pause until everyone is up to date. Then this is our first experience with radians. We're not going to have to do a whole lot with radians, but what you need to recognize that radians is a different way to measure angles. Just like we can measure the length of your desk using centimeters or inches, one's a metric system, one's the English system, we can measure an angle in degrees or in radians. The higher level you go in math, the more and more it will be using radians. So this is our first introduction to what a radian is. An entire way around a circle is considered 2 pi radians. It's the measure of the circumference on a unit circle. So a unit circle has a radius of 1. That part you don't really have to remember yet. What you need to know is how to convert between degrees and radians. So everything that's highlighted, again, copy down. So whoever is hitting pause, hit pause now. And then the last thing is arc length. Arc length is really easy to find if you are measuring in radians. You just take the radius times the radians and you've got the arc length. Again, hit pause. Okay, going on to the examples. First of all, let's just get familiar with drawing some angles. So we need to draw 210 degrees in standard position. So we'll draw an x and y axis. Now, standard position always starts on the x-axis. And if I go this far, that's 90 degrees. And then there's 180. So then how much over 180 do I need to go yet? So I think most of you can do this in your head, but that's what we're looking at doing. 210 minus 180 is 30 degrees. So I need to go 30 degrees. Well, I know if I were to go all of the way, that would be another 90 degrees. So 30 is a third of the way. So we'll just try to draw it in the best that we can, about a third of the way. And then we talk about the reference angle. 30 degrees is our reference angle right there. Now let's look at a negative degrees. So again, draw out an x and y axis. And this time it's negative, so we need to go clockwise. And we're only going 45 degrees. And so our reference angle now is a positive 45 degrees. Because reference angles are not positive or negative. They're always the positive form of it. But we just need to go negative, so we go down below. Okay, next example. A springboard diving competition. A diver has made a 900-degree rotation before slicing into the water. Draw an angle in standard position that measures 900 degrees. Okay, so start with your x and y axis. And let's draw one rotation, and that would be 360 degrees. Two rotations, how much would that be? 720. So how much more do we have to go? So we have 180 more to go. So where would that end up? 180 degrees is right there. And so our angle is right along the x-axis but in the negative direction. Okay, the next example. Find an angle with a positive measure and an angle with a negative measure that are coterminal with 210 degrees. Well, let's start by drawing out 210 degrees. So there's 180, and then it was 30 more. So it's right there. Well, a negative measure would be if we'd come this way. So remember we said that our reference angle here was 30 degrees. So when we're going negative, we went 90 degrees right here. And then this red part plus the black part has to make a 90-degree angle. So that means that this has to be 60 degrees. So the negative measure is 90 plus 60, or negative 150 degrees. Now the positive one would be if we did a full circle first, and then we came back around. So that would mean that we'd have to do 360 degrees first, and then another 210 degrees. So if you add those two together, you get 570 degrees. Now it doesn't ask for this, but what we could do is we could go around twice. Once, twice, and then go again. That would be another coterminal angle. So there's an infinite number of coterminal angles. I just need to have you do one positive and one negative. So now the shortcut of how to do this is you can take the angle and add 360 to it. 360. And you could take the angle and subtract 360 from it. And you're going to get the same thing. How about if it's negative? Well, let's draw this out. And we need to go back 120 degrees. So we go back 90 first. And then how many more do I need to go? That would be 30 more. So my reference angle right there is 30 degrees. Now this one, the positive one, is easier to figure out first. We went 180 up here. And then this other small section has 60 left because 60 and 30 have to make 90. So 180 plus 60 is 240 degrees. That's the positive one. The negative one would mean that you'd go all the way around once and then go again. So again, that's 360 plus 120 degrees. So 480 is our other one, but this time we went in the negative direction. Now this works the same way for our shortcut that I said before. So you take the degrees plus 360, and you're going to get 240. Or if you take the degrees minus 360, you'll get the negative 480. Next example, example 4. Now we're working on converting between degrees and radians. Now the conversions that you wrote down before are either pi over 180 or 180 over pi. And you just need to figure out when is the correct time to use each one. Well, we are in 30 degrees. So what you want to think about when you set up this multiplier is canceling out the degrees. And so which of those has the degrees on the bottom so it could cancel out? And the answer is this first one. So we're going to multiply this by pi over 180. So then think about the degrees canceling out. And then we'll go 30 pi over 180. But of course we can't leave it like that. We have to reduce it. And a lot of you can reduce that in your head. But if you can't, feel free to just grab your calculator because you will be able to have it for the test. 30 divided by 180. We're just going to ignore the pi for right now. Oops, I typed that in wrong. We're going to ignore the pi. Radians are always given in fractions. So I'm going to just reduce this fraction as 1/6. So you would write this as 1 pi over 6. Or another way that you would see it, that 1's not necessary, so we would just write it as pi over 6. And that's going to be our answer. Now let's go the other way. Negative 5 pi over 3. We need to get that into degrees. So again, remember our conversions are pi over 180 or 180 over pi. And we just pick which one we need to use. So let's write this out. 5 pi over 3. And we're going to times that by one of them. Now, degrees do not use pi, so I need to cancel out that pi. So I'm going to use a second one so that the pi in the numerator cancels out the pi in the denominator. So I'll multiply it by 180 over pi, and that's in degrees. So you cancel those out. And then you can just take in your calculator negative 5/3 times 180. And we get negative 300. And make sure that you label it degrees. The last one we did not label in radians because the fact that it's listed as a pi indicates that it is a radian. There are times, though, that radians will not be listed as pi, so that's why it was important here when it's 300 that we put the degree symbol with it. And our last example. We need to find an arc length. The steering wheel of a monster truck has a radius of 11 inches. How far does a point on the steering wheel travel if the wheel makes a 4/5 of a rotation? So let's draw out a circle and label the radius as 11. And just to kind of get a visual, let's think about going around 4/5. So let's maybe like that. We want to know what is the arc length. That kind of looks like Pac-Man. So we want to know how long this section is right here. Well, we had a real easy formula. It's just the radius times theta, but theta has to be in radians. So how many radians is 4/5 of a circle? Well, we know that 2 pi radians equals 1 circle. So what we can do is take 4/5 times 2 pi, and we'll figure out how many radians that is. So that is 8 pi over 5. And all I did there is I multiplied the 4 times the 2 because they're both numerators, because this is like over 1, and then 5 times 1. Okay, so let's plug it into the formula. The radius is 11. The radians is 8 pi over 5. And we're looking for a distance, and so we're going to give that in an approximate decimal answer. So type in your calculators. 11 times 8 pi, and use the actual pi button unless it tells you to use 3.14, divide by 5. And it's going 55.3 inches. Okay, the rest of the hour you have to work on homework number 2 on page 821. It is due tomorrow. You need to be using your time in class wisely. Also, remember that I will be checking for work. You have to show work on every single problem. So make sure that you are showing your work on them. On the ones where you need to draw out the angles, your work is drawing these little arcs right here. So make sure that you are showing your work, and then it is due tomorrow.